Hello, everyone. I think you can hear me quite loud right now. Wow, it's great to be here today. Thank you for the organizer to have brought me here all the way from London. Very excited today to have this talk with you guys. But let me first give me a quick introduction on myself. So indeed, I'm Cesare Valitutto. I'm a blockchain solution architect at IBM in the office in London. My background is computer science and artificial intelligence. And I've been working on blockchain technology for some time now, like 3 years and a half, like with IBM. And I have to be honest, it's been like quite an exciting topic, and still like it is. It's still on the hype of the big technology that is going to be disruptive. It already is like disruptive. It's going to be disruptive in the next few years. I really believe that. What I'm doing with IBM, so solutioning and architecting is a big task, actually. I'm a software engineer myself, so I'm coding. Today in this afternoon will be code labs. I guess few spots are available. I don't know like how many are still available, to be honest. You should check it out later on. From 2 to 4, there will be the lab. But most important things is actually creating a solution that somehow involve not just like the reasons of defining a solution that is a blockchain fit. You should find like the reasons why that kind of solution can fit a blockchain technology. Many times like there are different ways to reach the same conclusion, to reach the same solution with different alternatives, and blockchain is not always the answer. But I like to say, there is a nice sentence that someone before me says, like, I got the blockchain, what's your problem? So that's what I'm not going to solve today. We first analyze a problem and then we fit a solution. So one of the biggest issues nowadays is to actually architect a good solution in order to understand if that use case fits a blockchain technology or not. So that's what I'm doing right now in IBM. And today I'm going to go for this presentation, first of its kind about blockchain for techies. It usually takes more than 20 or 30 minutes. I will try to compress this in this time. And I'm very good at summarizing, but I will try my best. So let me go through this presentation, and I hope you are going to enjoy. Time for questions is later on, so please hold on your questions, and we will have 10 minutes later on to have all your questions on. So a quick look at the agenda. We are going to try to go through first to give you an explanation of a definition of what blockchain is and how that works, and then going through a specific blockchain framework that we use quite a lot in IBM. It's the Hyperledger Fabric, and I'm going to also like explain a bit more what Hyperledger is and what specifically Fabric is under the Hyperledger umbrella foundation. But first of all, let me go through this. A really like mind-blowing question, like, what's blockchain? Yeah, what's blockchain? It's also capital over there, like, to give more resonance to it. What blockchain means, and yeah, pro tip over there is not magic money going over internet, it's not. So, like, the real concept of blockchain is something that can be explained, for me, like in a simple formula, and in this one. Talking about blockchain framework in here, so what blockchain framework means, a simple formula, is equal to a ledger plus a smart contract runtime plus a consensus mechanism. Let's go a bit through what ledger means. The ledger is a composition of blockchain, as the name suggests. There is a complete history of all the transactions happening in a network. I'm going to explain this further. So just get all this information. We're going to collect all of them, explain it one by one. Just like going to give you an overview of this. Plus a worst state. It's not more than a database. So a worst state is what contains a snapshot, the current state of what are the transactions, what is the state of the network in that specific moment. An abstract of this, so looking a bit more under the hood, what blockchain is, as the name suggests, simply, it's a chain of blocks, not more than that. It's a data structure. And how like the picture can suggest are blocks linked to each other, a series of blocks that are built every time there are new transactions in it. There are a series of records that are stored inside these blocks, data, whatever. And these nodes are called blocks. And they're linked on each other through a specific rules. And inside each blocks, we have a series of transactions, data basically, a history of what happened along the network, right? So this transaction represents basically the value that is inside the network. So we can log all these. Today we can have a snapshot. We can go in any kind of block explorer available online and read everything that happens on the history of Bitcoin from the really beginning till now. So we can see everything is written in Genesis block, everything is written in a transaction that we use it to send money to friends and so on. So that's everything available for everybody, it's transparent. And the main concept that connects blocks to each other is nothing more than a linked list, if like talking about like more in techie words. And this linked list is based on a fingerprint that's called hash. Each block contains the hash, that means a fingerprint, that means a calculated function of all the data that is inside the previous block. And that's for a very specific reason. And that's because we can actually validate and check that that specific block that we are creating contains exact all the history before. So one only bit we corrupt inside the previous blocks will make this fingerprint being different. So we will not have the same fingerprint of the previous block. And that makes difficult to corrupt and to change a blockchain with something else. So to corrupt the blockchain, to create different blocks. And this base structure maintain the network fair. This is something that very mathematical, like they study quite well how to build these things in order to have a more solid structure underneath. But its most important concept, and something I very want to stress on and underline, is a concept of decentralization. Something that is coming out with something that is called peer-to-peer protocol. That it's come out like a time before with some peer-to-peer protocol communication application that allow us to exchange data and files. But the same protocol can be used to exchange any kind of data, you know, and also like can be used in business, can be used nowadays to do everything we think is thinkable to do. So that's a big concept. Something that we should abstract. Bitcoin is just an idea of an implementation of what decentralization means, but we can actually look at this at a more higher level. What blockchain is also one idea of that. Distributed ledger technology, that is a bigger category of this, in which blockchain fit in, is a decentralized way to exchange data, in which we don't have a single owner. That's an important concept. We don't have a single owner owning that data. We have a group of people that can be all of us, that can be a restricted number of people based on their own business, on their own specific work that they do, that own this data on the same level. So it's on a horizontal scale. It's not a vertical hierarchical scale. So there is a kind of open governance of what is inside the blockchain. Each one of these parties are an identical replicas of this data structure, this database. Right now, what we see in the real world is that people, participants of a specific business, banks, or looking more specifically in a common supply chain of a distribution of a car from a supplier to a final recipient, we have a series of steps, a series of participants on this network, and each one of them holds a different registry, a different blockchain thing, a different database in their own side. And that makes things, of course, like complicated to update, cost effective, and in maintaining this system. The identical replicas allow us to maintain a transparency between the parties. So we know that what is actually on your side is on my side, it is the same. We don't need to trust each other on words. We can trust each other on facts. And that's the most important thing, especially for business. So membership can be open or private, as I mentioned before. And we are gonna explore this more in details later on. But let me spend 2 words also on one of the biggest myths and famous in its kind, Bitcoin. One important thing that I want to say and state today, I know that many of you already knows, but Bitcoin is not synonymous of blockchain. They're not the same. They're not interchangeable. Bitcoin is an implementation of blockchain. So as a blockchain underneath, as a data structure. And is the most popular example of that technology, how that technology has been used. The mother of all the blockchain frameworks. Mostly, Bitcoin is not BTC, and I wanted to specify in this way, just to know the group or bunch of people here are using to play with or invest in cryptocurrencies, that they are 2 different things. So we need to separate and distinguish between Bitcoin as a protocol and BTC as a cryptocurrency. So what is the world of doing business or exchange data is different than a world of cryptocurrency speculation market that we have on the other side. So we separate these 2 fields completely. So today we are talking about protocol and technology. We are not talking about cryptocurrencies. So I'm just gonna code it today, and we are not gonna see anymore this word in the presentation. Cryptocurrency are digital assets that are part of the protocols and built in using blockchain technology. They are mostly part of permissionless blockchain. While permissioned blockchain, they don't have a concept of cryptocurrency. I know I'll keep you with this mind-blowing permissionless or permissioned, what that means. Right? Let's have a look at that more specifically, because I mentioned before open and private. I don't like too much to use these words because private means that not everybody has access to that blockchain, but potentially they could. So I like to mention permissionless and permissioned because I think it's more correct as example and division between the 2. And I'm going to give you few of the main differences between the 2. Left permissionless, Bitcoin-like, or Ethereum-like, or permissioned on the other side, like Hyperledger Fabric or Corda or Quorum on the right. So the main difference is the public access that we have on something like a Bitcoin network. Today we can go, again, on any kind of block explorer, or we can create any kind of wallet in any kind of way, and we can be already part of this network. We can run our own node, we can have our own blockchain ledger running on it, on our own computer, so we can actually host a Bitcoin node and be part of the network anytime. In a permissioned, you should know who is actually part of that network to join. So you're not just like gonna join downloading a node of the ledger, but you should ask for permission to enter. So it is more control, access to that kind of data, and that's because it's a data that contains information that are related and worth for business. And of course, if you are meant to be part of that business, you should be in. Otherwise, you should not see what is actually in there. About speed, this is mainly concept on the fact that throughput of transaction in Bitcoin, as we know right now, is quite slow, and that's because of the validation process that's behind that. And this is related to the below one. And permissioned blockchain frameworks are faster in speed, so that we can have a throughput of transaction in the order of thousands per second. And that's because the validation process that's behind is different, and it's not based on proof of work, on proof of stake, but it's more like pre-authorization. So we know who is interacting, we know who is the right to interact with things, and there is a different process that depends on blockchain framework implementation. We are going to see how in Hyperledger Fabric this is reached. But let's stick on the concept that we validate transaction not using, not calculating things. So we don't burn energy or much energy as much as with Bitcoin. You know, we don't do the same calculation and process to validate transaction. It's a different process. And another important feature is anonymity no identities over anonymity for the permissioned blockchain. So while in Bitcoin or in other open blockchain, permissionless blockchain, we have the concept of hash of our wallet. So actually we have a public address of our own wallet that identify not necessarily a person behind that. Could be a company, could be whatever entity, we don't know. So can be anonymous or pseudonymous in a way, because like we still can trace back probably who is behind that, but it's not directly associated to an identity. While we know who we are transacting to and with in the permissioned blockchain, so we know exactly who is the party behind that. So we know we are transacting with John, on James, on Mary, on Katie. So we know exactly who is the person behind that. So we have an identity, we have a certificate that identifies the person univocally. And most of the times in the permissionless, we have a built-in asset like Bitcoin, like Ethereum, while in a permission we can exchange any kind of asset. So it doesn't matter, that can be tangible, intangible, can be money, can be ownership on things, can be houses, can be cars, can be whatever you think now, you name it. So we can have different assets. We are not strictly connected to any kind of asset or cryptos that we have in there. So there are not tokens, there are not coin, in which we are bound to. And that's why we can talk about exchanging any kind of data, more specifically. Let's have a look at an example of a permissioned blockchain. Hyperledger Fabric. Let me spend 2 minutes talking about what Hyperledger is. So Hyperledger is a community effort of many companies that group with each other trying to build blockchain solution for business. So enhancing the quality and the capabilities of the code of different blockchain projects to try to create something new and cooperating all together to create something different and extremely disruptive. It started like 3 years ago, end of 2015 actually, and today it started as a let's say it's an accident. It started like an example of things, like Hyperledger Fabric specifically started in a hackathon in which Digital Asset and IBM working together to build some new blockchain framework to host business. But Hyperledger itself is under the Linux Foundation, so it's an open source community. All the code is released freely on the web, so on GitHub, on Gerrit. You can find over there, you can contribute today. So that's the main important things. Today you can go and add your own feature, your own code, create a pull request, send it over there, and you can be part of this project. So you can put like yourself in a big step in the history, being part of one of the most disruptive community that is the one of Ledger, that today counts more than 100 members from any kind of industry. So we're not talking just about IT. IBM is one of the member, a good contributors, like premium member of the Hyperledger Fabric, together with Digital Asset, with Accenture, and many others, American Express. So from different kind of industries, from technology side, IT, finance sector, energy, banking. So we have banks, BNP Paribas from France. We have Mitsubishi Bank, Deloitte, Walmart in the supply chain industry of food. So many of them. You can see all the list of them on the website of Hyperledger. But the most important thing is open governance. So the fact that all these groups are together, they allow us to define a fact that is not only one concurrent, one participant, one unique organization that is leading these things, but all together bringing values for the world, for the people. Say that. Hyperledger Fabric is one of the framework that we mostly used in for my work in IBM. I've done many projects with that. I can count more than 10 or 15 MVPs and proof of concept. Some of them went production as well. So we are one example of a great product using Hyperledger Fabric that I'm in production right now. One of the early ones was Hyperledger. For provenance of diamonds in the beginning. Now is becoming like more provenance of many other things, like wine, art pieces, and more. But you can do like many things with this framework. So you can do provenance, you can do traceability in the supply chain, you can do finance, you can track energy. I was part of one very interesting peer-to-peer energy trading project that I made in a hackathon in Tel Aviv some years ago. Very exciting one. You can do many things, and I suggest you to have a look on the code of that, to play a bit. There are nice tutorials how to getting started. But let me go through like a few features that identify Hyperledger Fabric in a very game changer in blockchain technology framework. So Hyperledger Fabric is, as I mentioned, like have the concept of identity over anonymity. We can identify who is like we are talking to. The validation of the transaction happens through a process called endorsement. We are going to see like it in a few slides. There is a big concept of privacy and confidentiality. And that's mostly on the fact that we want to be transparent with the people that we choose to be transparent with. You know, like we want to share some data with specific people on us. So the main concept is like we still are doing things that is in a way like confidential, because we want to apply this not just in a normal case of exchanging pure public information, but we want to also be able to exchange private information. And that's why like Hyperledger Fabric especially like focus on data segregation features and confidentiality. And the modularity, this is another part of Fabric. Fabric was, it came out and was born with the idea of giving as much flexibility and freedom as possible to plug in and out modules like data storage or databases underneath, connected to the ledger, to the blockchain, or a process of certificate authority, so how to identify user. Like today is possible to connect different certificate authority or member service provider to Fabric. And particularly is like it's open architecture, so as well you can have a look completely at the architecture, how it's built in the technical perspective. And again, if you want to participate to the project, there is a Jira board in which all the proposals are running, and you can be part, chip in, go in there and see like if the proposal like actually like you can actually vote for it, and that can be pushed to be part of the next features release of the product. So they're moving quite fast. We are in version 1.3 released in October, this October, and having like many features, very interesting. Okay, great. So after all this talk and chatting, let's deep dive directly on how Hyperledger Fabric works. So I'm gonna give like a few slides to look on this overview and to see like the main components that we see in this slide. So I just want to show some part of them here. Always forgetting that we have a left side. So on this part of explanation, I'm gonna go through a few components that you're going to see on the slide on the transaction process. A client that is not more than a client application. So what you're going to see from your application side built in whatever language you want. There are SDK that you can use to connect to Fabric. And this SDK will be able to, you will be able to initiate a proposal, transaction, submit transaction, and send some specific like operation like install instantiated chain code, create channels, and other kind of operation that you can do with Fabric. You will be able first to send this kind of operation through the SDK. The SDK will be connected to a peer. There is two definitions of peer. As you can see, I want to maintain the same shape of them, so that there's a hexagon to say that it's the same peer and endorsing peer. They are the same base in code, but they are different responsibilities. So a simple peer will maintain the ledger and state, will commit transaction on his own ledger, and may hold a chain code. It's not necessary that a chain code is there. It may hold a chain code, while the endorsing peer specifically have the task of endorsing a transaction. So it's a peer that is assigned, entitled to receive a transaction that is flowing through the network and validated based on some specific policy. So it's validating against a smart contract. We're going to see what smart contract means, like in a few slides, in the next one actually, and must hold a chain code to do this validation. So this transaction will run against some rules, and it will be validated against these rules. So if it's valid, we are going to sign the transaction and send it back our result and response. The order, it's a very interesting part and component of the Fabric architecture. The order has the specific task to create a blocks and distribute them. It doesn't have a task to validate. It's a task of ordering transaction that it will receive, put them in block, cut the block, and send the distributed through the network to the specific peer that needs to receive them. It doesn't hold a chain code. It doesn't hold a ledger. It doesn't need them. It doesn't need to have information about that. So it's a pure technical role. Let's have a look at what smart contract means. Also, misspelling this like smart contract, it sounds like confusing. It's not just a more clever, intelligent contract, digital contract. It's not. Sorry to say that, but the way is it defined in most of on the framework in Fabric, especially it's a chain code that maybe give more the idea of something that is coded. There are mainly rules. There are specific functionalities and operation that allow us to understand how to use, how to do things on the network. So in the example of a car, when we build the car, we would like to have operations on the blockchain to paint a car, to transfer a car from an owner to another. So these are kind of operations that we will have on our smart contract, on our chain code. So this operation will, of course, have some rules which, like, the endorser will need to validate us against too. And each call to a chain code app that somehow modifies the state is called transaction. So a transaction is whatever kind of operation that's modified the state, that it creates or modifies data inside the network. Let's say painting a car is modifying the color of the car, is a transaction. Whatever can be logged. So it's not a query function that we just get data, but it's more like I apply something, so I'm storing something, I'm writing something in, and that needs to be stored. This is transaction. And important to say that a chain code is stateless. It doesn't maintain any state. If that chain codes go down, there is not data that it was holds in the container, in the specific component of the chain code running. So this is also make our network safe of any kind of bad functioning. Political endorsement, policy endorsement. Transaction must be endorsed, as I mentioned. Like, this is an example. Like, a policy can be very simple. I would say, like, we need a validation at least from one member of each organization. So we have 3 organizations in our consortium, in our network, and we need all of them to put a signature on that transaction. So we want to be sure that each one of them validated, they have the same rights, they have the same governance on this network, and they have the specific rights to put their signature in it. If one of the signatures is missing, for whatever reason whatsoever, then that transaction will be rejected. And that's the way in which actually Fabric maintain and solve the problem of not deterministic transaction and avoiding there will be a double spending. So this process is done before. We are going to see like more in details in the next slides, but keep in mind that there are some peers in each organization that have this kind of role, and it's a process that in the really beginning needs to be done to validate that transaction. The ordering, as I mentioned, the ordering service doesn't have more than a technical, it's a very important one, but it's a more technical work that is the one of cutting blocks from transaction, and this operation is under like 2 specific rules, size and time. Basically, like how many transactions I set to be part of a block, and the time. So how many transactions I can handle per time, and that's going to be the size of my block. So based on these 2 variables, as an example here, I can define rules to have a specific size of blocks and how the ordering will work. The ordering will process this transaction with other orders for part of other organizations, so they need to reach an agreement, a consensus through different algorithms to, in the end, create a block. So the block should be the same everywhere. So they will agree first on how to order this transaction. Once they have that specific order, they'll create a block and distribute it over the network. Well, let's see in a specific how a transaction flow works in Apple Fabric. As I mentioned before, the client application will basically submit a proposal or a transaction. So it's not a transaction that is going to be written directly. It's something that I want to propose my transaction to the network, and I send this to the endorsers in parallel to the many endorsers that we have. I want to show just for example in here that we can select some specific endorser in the network. We don't necessarily need to have all of them, all the peers. So we can select a specific range or group of them that it will do this operation. So in this case, selected 1 in organization 1 and 3. So this is going to be, the proposal transaction is going to be sent to them. They will do some validation. That means they will process that transaction, and this transaction will be processed against a chain code that they have based on their rules. They're going to evaluate it based on some specific data, reading data and writing data. They're going to store this information. So what's the data that I read? What's the data that I've written? And they're going to send it back to the client saying, this is valid for me, or this is not valid for me. So I'm going to put a signature or not, and say if this transaction is valid or not, based on specific rules and operation that I have in the chain code. So I'm going to send it back to the client. The client will receive confirmation from the endorser, and then it's time for him to send it directly to the order. The order, of course, like we'll see, validate this based on, we'll just check if like the endorsement policy simply contains the signature that are specified in there. It doesn't make any calculation, it doesn't do any specific reason. We'll just check policy and signature. If they're fine together, then they're going to accept that transaction and elaborate it. Once the order service, so that can be many orders, are like aligned and got consensus together, reach a point of a consensus, so they would know how would be the order of that transaction. Then it will send it back to all the peers, part of the network. So in this case, also the peer that was not endorsed will receive the block, because they are storing, in that case, the ledger on their own side. So they would be aligned with the same blocks altogether. So they will again calculate, before committing, that this read and written data is the same that they had before, so that there will not be corruption, and there will not be double spending in that case. So there is a double check. And if that is all correct, they will store the new block, connect to their own ledger. This ledger will be synchronized and completely the same on each of these peers. So they will have the same source of truth. And they will send it back their response to the client and say, okay, we added this block. This is the event that generates your transaction. Your transaction is stored, is valid, and you can go ahead with the other. But let's have a look at one important concept that I mentioned before, privacy and confidentiality. Fabric has an important features that it channels. So I will define it that as a multi-chain or multiple ledger. So peers can hold multiple ledger based on the kind of channel they are. So we can define a channel that is specifically related to channel A, for instance, specifically related to finance. So we will do all the finance operation over there. Related to account. Channel B is, for instance, a channel that regards transporting, so it doesn't need to hold information about accounting, about money, about financial financing of any kind of peer in this. A channel C could be, for instance, a public channel in which all the peers are in, and which we want to share, for instance, all the information publicly with all the network. As you can see, like more down there, like these channels are completely separated. Peers are channel agnostics in a way that they don't know, they don't have information, they don't have a possibility to see like what is in the other channel if they are not part of. So each channel has a separate ledger. Each channel has a separate ledger and blockchain, right? So that's why it's good to define like a multi-chain in a way, because they are kind of a small network within the network. And the peers that are not belonging in these channels, they will not receive the block from the order. So the orders will know to which peer send the specific block related to a specific channel. So this is a very interesting feature. That means we are not encrypting data. We are not hiding data. Data will not just be there to the people that don't need to receive it. And most importantly, channels can communicate. So there can be a cross-communication, cross-channel communication from each other, from a smart contract to another, only in a read-only fashion for now. An overview about the identity process is also very important in Fabric. We have a certificate authority. Fabric is based on a public key infrastructure, so public and private key. Private key is used to sign, while the certificate or public certificate is used to be identified on a network. So I know who I'm talking to in that moment. And when I sign a transaction, I sign with my private key, and that, of course, private key will sign the transaction, and I'm always able to identify the transaction through my own certificates. Private keys are stored in a local member service provider. So clients, order, and peers, they will have their own local member service provider, will store their private keys safely, so are not running across the network, they are not stored anywhere, anywhere in the network publicly, so they are stored locally from their side. It's important to specify. The usage of them, as I mentioned, is on about transaction proposal. They are signed with a private key of the client that are using that. So a specific user will use that that key to sign the transaction and send it over. So we know that that specific user was the initiator of the transaction. The order will sign the blocks, will send it over, so we know that actually there is a trusted entity behind that block. We are not just receiving the blocks for whatsoever appear in the network, so it's signed by the orderer, so we know that it's approved by them, it cannot be corrupted. And this scenario, of course, verified like during the endorsement process, like this enforced trust in the network. And this is like help us to identify the specific user behind that transaction. So that's also a feature that helps us not to use a proof of work, because we know each other, we know exactly who is transacting and sending the transaction, and we can identify backtrace with a specific certificate who is behind that transaction. Right, so many contents over here, I know. Maybe if you want to like look more, we will have like a workshop later, so you can just like pass by, stop by for the question and information. But just summarizing what we have seen today. Summarizing what blockchain means. Blockchain is like a list of blocks of validated transactions linked to each other. A blockchain records the assets and it can be controlled through smart contract. And this specific data structure is immutable. It's tamper-proof and is the only source of truth. That's very important. And what Hyperledger Public is, in a few features that we have seen, like is a distributed ledger based on blockchain technology. It's based on signed and trusted transaction. We have known identities and not proof of concept in here. And more on saying like the shared governance is very important on the framework. So the fact that we actually have the endorsement policies allow us to define, we can actually put their like words on a specific transaction. That's really important for business, because we want to all know that all us in a big consortium agrees in what is happening in the network. That's really important. Something that is like not very clear right now. So this is increased transparency and trust across the network. The confidentiality part through the channels, so data segregation, this is an important feature of Fabric. They're doing, and is released now, something that is called private data collection. There's also a very interesting one to increase more confidentiality. And the consensus algorithm behind all the process of transaction flow, endorse, order, and validate. This is pretty much what I wanted to talk today. Thank you, everyone. Go and listen to these things. If you have any questions, and please stay in touch.
კითხვები ვისაც გაქვთ, ხელი აიწიეთ და ნუ მიკროფონს მოგაწვდით.
One over here.
Hi. Two questions. First one is a really small yes/no question. So, orderer is a single point, one entity you have in your blockchain, or it's also distributed, so one of the peers can be at the same time orderer?
Can be distributed, yes.
Yeah, okay.
Yeah.
And the second question about this multi-channel system. So, mainly still blockchain is used for fintech transactions, cryptocurrencies and stuff like this. Recently, I see lots of cryptocurrencies introducing secret transactions where it's actually stored in separate channel and only the sender and receiver knows the transaction happened. So I have a question. In such cases, for example, in cryptocurrencies, I don't know, maybe there is some implementation over your framework you are saying of the same technology, but it's more general question. So when we have some data in separate channel and we want to somehow use it in public blockchain also. So private transactions that we made between me and you only, and then I want to make some other transactions that I'm sharing publicly to everyone. But I should prove that I own that amount. That also includes transactions that happened between us also. How these cases are handled?
So that's a good question, actually. As I mentioned before, like there are different ways. One, I think that the best way to maintain monolithic procedures of the network, how like Fabric works and the specific framework is the cross communication, like cross-channel communication. So the fact that from
There's some cross-channel communication.
Yes,
You can
yeah.
expose some data from single channel.
Yeah. So what's if two peers are actually part of the two channels that you mentioned, a private one and a more public one, what can be done from the public smart contract, that can be a read operations on the private smart contract to actually check if that account it's actually owns and have some money in that.
So smart contracts just validates or rejects it. It's true or false, like.
Yes, can be
okay.
it can be like a communication between the two, and when it happens that things as like the endorsement policies is checking these across against like smart contract rules, what will happen in that case, that will deny the fact that that operation is valid because there are no money, and that rule specific, like if there are no money, just reject this transaction. So that's what will happen.
So still information between whom happens this transaction remains private, but some smart contract verifies that you have this money at your your
correct.
Okay,
that's correct.
Thank you.
It's actually sorry, like to connect this to a very nice concept that it's in open research right now, and also in Fabric they're working on it. Is some concept of it's called non-knowledge proof, like zero knowledge proof. And it's on the fact that you can actually prove something without exposing data. Like answering to your question, for instance, I just want to check if you have money. I don't need to know how much money you have. I just want to answer to a simple question. So that's something that would be possible. It's already possible in some framework. They are studying on it, how to implement it on Ecologic Fabric as well. So,
Hi.
Sure.
I have two small questions, but before that, by the way, the presentation was great. The only one that I've heard that made blockchain really click in my head. But as I was listening to your presentation, I saw some similarities between this Hyperledger Fabric and Ethereum. As we know, they're both platforms used for these kinds of things. So I was wondering whether your Hyperledger Fabric framework also has a kind of a DSL that Solidity is like. So Ethereum for smart contracts has their own DSL to make stuff a lot easier. Do you have any specific
DSL spelled DSL?
Domain specific language?
Oh yeah, the language in which like the Fabric smart contract is written is natively in Go. So Hyperledger Fabric is written in Go. But they allow him to write smart contract in many different languages. This is also like another important feature. So you can write in Go, you can write today in JavaScript and TypeScript, you can write in Python, you can write in Java. So there are many other languages. So there are no specific language in which like Solidity, and I invented like on purpose for Ethereum, but you have many other languages to write that. So get a bit easier.
Thanks. And the second question, say for example, if my organization wants to like create a system for management and decision making and make it democratic and have like votes for each member, I would generally resort to using Ethereum to implement that system. But could you like tell me why I would use Hyperledger Fabric over Ethereum in that kind of specific scenario?
Yeah, it's a very good and hard question in a way. Like it really depends on a lot of things, a lot of factors in this. So you should consider many things. There is not, again, there is not like one solution, unique solution. Usually that's is also like part of my work in finding different alternatives. You know, like there would be many ways to do things, and actually, if you think that Fabric will fit more in a situation in which you need a high-level throughput transaction, you need to know your parties, you want to really be sure what you're transacting with. So many features that you will need to consider before like picking that specific solution instead of another like Ethereum itself. The fact that there are no transaction fees, there's also like not important things on this framework, as many others. So it's more related to doing a kind of business, day-to-day business in a way. So it's more oriented to that. and to cover as many use cases as possible, as much as in this decentralized application and Ethereum as well. But indeed, like it's really the choice of it will be very focused on the specific your specific needs. I would say, like, so you really need to take care of answering some specific question and see if that specific technology fits your use case or something else will fit.
Okay,
Like
thank you.
Thank you for your presentation. I have one question.
Sorry, I
From
cannot
here.
spot it. Oh, okay. Where? Sorry. Oh, sorry. Yeah.
Thank you for your presentation. I am from the University of Georgia, and I have one question. How do you think there are many blockchains, Hyperledger, Ethereum, Cosmos, or Corda, and how do you think which one is preferred or which is better at this moment?
Taking
prefer
myself out of the
Hyperledger,
part,
but-
you mean, like taking my shirt out, you mean, and well, I have to be like fair on the fact that I'm following up more Hyperledger Fabric. So I don't know much more in any other frameworks like Corda or Quorum on others. Of course, like I'm following more the Hyperledger Fabric concept. So it is also like about it's not just about the features that are coming in that are available right now. It's more like what's the idea of a roadmap, what is behind the project, and looking at something that is open governance and allow us to actually chip in and give our own solution and proposal. They actually give me the idea that whatever will come will be part of a community, so will be more related to us in a way. So to say what is better, again, like coming back to the same question, what is better, what not, the main feature really depends on your own ways to interact, so of your own specific needs. So, but yeah, of course, like that, I'm a part of it because I'm following more the project. I've been working on that for pretty much 3 years. So I see the evolution that they made based on the suggestion of the people that were using, and of course, it's a very promising project, and what they're doing right now is it's something that it really fits like the needs of many people like on the globe. So, sorry if I can answer your question any better, but really I don't have an answer like on this. It really depends on features.
ბოლო კითხვა მეგობრებო.
More time for some questions?
Yeah, last question.
Okay, good.
Hello. I have a simple question and maybe not very simple. I start for simple.
I like that.
So as I see that permissioned blockchain is more suitable for storing information related to elections and other political sensitive information. Is it correct?
The permissioned blockchain, sorry?
Permissioned blockchain, as I see, is it more suitable to store information related to elections and other political sensitive information?
If it's more suitable for a specific data, for specific information.
To storing information about elections, voters, their voters.
If it's more suitable, I would say like that allow you to control the data better, so you have more control on that data. It's another concept, I don't know if you mean specifically some kind of personal information or like some political information, you say?
I think about special case when it used it for digital democracy. The storing voters lists and other information about elections.
Like an example that you can give me is?
For example, information about referendum and voters about the referendum questions.
Right, so like a liquid democracy of is well, it depends on what you want to achieve with that, because if it doesn't say that you can do that better or worse, so it doesn't have a quality of that. It depends how you want to shape it. So if in that specific use case you want to maintain, like I see that, for instance, like is a more like public vote, right? Like for a referendum. So that should be probably open to everyone. And if you had to identify the user that is behind that, like that you need a framework that allow you to identify a specific user behind that transaction. So I would say yes,
And
because
as a question, how that Hyperledger fabric can deal with cases when user's case compromised, expired, and or devices with them stolen. Is it possible to verify old data changes paid by user whom old case expired, stole, uncompromised?
absolutely. So like what you can do, like with certificates, you can revoke your certificate. So you can that certificate will expire. So whatever is running on the network with that specific key will basically be rejected, and you will not be able to use it. More specifically on Hyperledger Fabric network, if you are a member and you're using like a stolen certificate, you'll be actually being taken away from the network itself.
I asking about different. There was changes made by user using a KA. Now he got a KB by some reason. And can I use somehow still old data, old changes made by him, maybe after rebuilding the database from scratch?
Rebuilding the database, rebuilding blockchain, no. So that's not something that you're gonna do. So like what you're gonna do is just adding a new transaction that will update the previous one, so the state of the previous one. You cannot delete information. You will just put things on top. Like we can have a chat later. I will have a also workshop.
Yeah,
later
basically,
on.
guys. So Cesare is here all the day. So even he's like making the workshop in Code Lab. So anytime you can find him, you can talk with him, ask anything. So talk with him. No problem with it. Thank you, Cesare, very much. It was quite interesting. Thank you.
Just like.